All right, on to question 3 over here. Same question as before. We have 39% of the cars have a built-in DVD, 21% have a GPS, 47% have at least one of those features. So in the last question, we answered the notation over here. Now we're actually going to find the probability that a car has both of these features over here. So we have the probability of DVD, which is 0.39. We have the probability of GPS, which is 0.21. And we have the probability of DVD or GPS, which is 0.47. Now we're trying to find the probability that a car has both of these features. So we are looking for the probability of D and GPS. So DVD and GPS. And so we don't have independence over here, so we cannot just multiply the probability of D and times the probability of G, because that only works for independent event. We do have dependent events over here. So what we have to do instead is go to the definition of the probability of D or G, because remember, when we have two events that are not mutually exclusive, one of them is the DVD, the other one is the GPS. The probability of D or G is anything shaded in here, which is really the probability of D plus the probability of G minus that intersection, because we will have counted that intersection twice. So our formal probability, which is the formal addition rule, states this: the probability of D or G is equal to the sum of the probabilities minus the joint probability. And this is exactly what we're trying to find out here. So let's plug in all these values. We have the probability of D or G is 0.47. The probability of D is 0.39. The probability of G is 0.21. And then we have to subtract out the overlap, which is actually the probability we're looking for in our case. So we have 0.47 over here. We have 0.6. And then what do we have to subtract from 0.6 to get to 0.47? Or simply we can take the probability of D and G is equal to 0.6 minus 0.47. Subtracting those two from another is 0.13 over here, which is our final answer. So it does take a little bit of work to get to this probability, but we are going to use that formal probability rule for our addition rule, or you're always going to think of addition.